Welcome back to another deep dive with the All Sorts podcast. We're the place where curiosity meets clarity.
That's us.
Now imagine stepping into this ever-expanding universe of knowledge, right? Where every corner holds a new discovery. That's kind of what our archives are like here at the All Sorts podcast.
A lot to explore.
Definitely. So before we get started today, maybe pause for just a second. Head over to YouTube. If you like what we do, give us a thumbs up. Maybe share it with a friend who's just as curious as you are.
And hit subscribe. That way you won't miss any future deep dives.
Exactly. Think of it as adding fuel to our exploration engine. And hey, the chat doesn't stop when the recording does. Find All Sorts podcast on X, Instagram, Threads. Keep the conversation going.
Yeah, connect with us and others. It's a great community.
So today we're tackling something huge. A technology that's, well, it's everywhere now. Large language models.
LLMs, yeah. They're really reshaping things.
They absolutely are. And you, our listener, you pointed us to some great stuff. We've got this really comprehensive survey on LLMs, some background from Wikipedia, and insights from Snorkel AI, too.
A good mix of sources.
Yeah.
Academic and applied views.
Right. So our mission today, let's break it down. We want to really get our heads around what large language models actually are. You know, how do they work deep down?
And why all the buzz? Why are they such a big deal right now?
Exactly. I mean, everyone's heard of ChatGPT, seen the headlines, but we want to go deeper. So the logical starting point, what is an LLM?
Okay, so fundamentally, large language model, the term itself, kind of signals a big step up from what came before, which were pre-trained language models, or PLMs.
PLMs, okay.
Yeah. These LMs are PLMs that have just been scaled up massively. We're talking tens, sometimes hundreds of billions of parameters.
Billions, that's hard to even picture. And there were smaller ones before, right? Like the sources mentioned BERT.
Exactly. Models like BERT were, and still are, super important. Snorkel AI flags BERT as a key development, but LLMs are just bigger, much bigger.
Okay, so they evolved. Where did they come from? It wasn't just bam, LLMs exist.
No, definitely not. The survey traces the lineage pretty well. It started with statistical models, looking at word frequencies and patterns.
Old school stuff.
Yeah. Then came neural networks, which could grasp more complex language stuff.
Yeah.
But the real game changer, which both the survey and Snorkel AI really point to, was the transformer architecture.
The transformer. Heard that a lot.
Right. These pre-trained models built on transformers, trained on just insane amounts of text data. That's the foundation.
And the scaling thing seems critical. The survey talks about model scaling. What's the deal there? Is bigger just always better?
Well, it's more interesting than that. As you rank up the size, the number of parameters, they don't just get slightly better at the same things. They start showing completely new skills, abilities that just weren't there in the smaller models, like in-context learning.
In-context learning.
Yeah, where the model can learn what you want it to do just from the instructions and maybe a couple of examples you give it in the prompt. No extra training needed for that specific task.
Wow. Okay, so you just tell it what to do, maybe show it once or twice, and it figures it out.
Pretty much, yeah. Smaller models like BERT couldn't really do that effectively. So the size isn't just for show, it actually unlocks different capabilities.
Yeah, it makes a lot more sense. It's not just about raw power, it's about emergent qualities.
Exactly. Emergent abilities. That's a key concept we'll come back to.
Okay, so that's the what. Now the why. Why? The huge impact. Why is everyone talking about LLMs changing the world?
Well, the survey calls it a revolution for AI. And you can see why. Models like ChatGPT, GPT-4, they've really forced everyone to rethink what AI might be capable of. Snorkel AI talks about this ChatGPT moment too.
Yeah, suddenly the idea of artificial general intelligence, AGI, felt closer.
It definitely brought it back into the mainstream conversation. OpenAI's out there planning for AGI. The survey even mentions the argument that maybe GPT-4 is like a very early version of AGI.
Serious stuff. So how is this impact playing out in different areas? Let's start with their home turf language, NLP.
Right, natural language processing. The survey highlights how LLMs are becoming these kind of general-purpose language problem solvers. It's shifting the whole research paradigm.
Instead of building a specific model for, say, translation and another for summarization.
You have one massive model that can potentially do both and more just by prompting it differently. It's a huge shift.
Okay, what about finding information? Search engines.
Big changes there too. Information retrieval, or IR, The survey points to AI chatbots like ChatGPT and how LLMs are being baked into search, like with New Bing.
Right, so you're not just getting a list of blue links anymore.
Exactly. You can ask a question, have a bit of a back and forth, get a synthesized answer. It's a totally different way for you to interact with information.
And it's moving beyond just text, isn't it?
Oh, yeah. Computer vision is getting pulled in. The survey talks about vision language models like ChatGPT, but they can understand images, too.
And GPT-4 itself can handle images, right? Multimodal input.
That's right. It can take in text and images. The boundaries are blurring.
We're already seeing these tools pop up in everyday software. The survey mentions Microsoft 365 Copilot.
Yeah, helping with emails, documents, spreadsheets.
And ChatGPT plugins doing specialized tasks. Snorkel AI also notes this practical impact, like enhancing search or even helping write news articles. It feels like early days still.
Definitely just scratching the surface.
Yeah.
Which maybe brings us to how they actually do all this. What are the core techniques?
Good transition. The survey breaks it down nicely. Let's start with pre-training, that foundational step.
Okay, so pre-training is basically teaching the model the language. The survey explains it's mostly trained as a text generator. Its main job is to predict the next word in a sequence.
Like a superpowered autocomplete.
Kind of, yeah, but on a massive scale. It learns grammar, facts, reasoning patterns, biases, everything that's in the text data.
And that data is key. The survey mentions general data.
Right, like massive scrapes of the web, huge collections of books, conversational text from forums or chats, things like Common Crawl. Broad exposure.
But also specialized stuff.
Yeah, multilingual text, scientific articles, the Artsy dataset is mentioned, and tons of code. Models like Llama, the survey notes, use a specific mix, heavily weighted towards web pages, but including code and books too. Red Pajama is another big dataset example.
Okay, you've got this mountain of text. How do you get it ready for the model? It can't just read messy web pages directly, can it?
No, there's a lot of work involved. Data pre-processing, the survey outlines it, collecting the data, then cleaning it up.
Key things like what?
Removing duplicate pages, filtering out low-quality stuff, trying to catch toxic or harmful content, although that's really hard. Then tokenization.
Tokenization, breaking the text into pieces the model understands.
Exactly, into tokens. Wikipedia mentions byte pair encoding, BPE, as a common method. It's about finding a good balance between characters and whole words. And you use special tokens too, like for unknown words, or masking things out during training.
And the survey mentioned data scheduling, like planning the model's reading list.
Yeah, basically. 2 parts. Data mixture. What percentage of web text versus books versus code do you use? And data curriculum. Do you show it certain types of data earlier or later in training? The Llama mix is a good example of setting that mixture.
Okay, data prepped. What about the model itself? The architecture. The survey emphasizes the causal decoder.
Right, that's the dominant style for models like GPT, OPT, Bloom. Causal means it predicts the next word based only on the words that came before it.
So it can't look ahead in the sentence.
Nope. The unidirectional attention mask enforces that. It reads left to right, essentially predicting what comes next.
And this is built on the transformer architecture we mentioned earlier.
Correct. The transformer, as the survey, Wikipedia, and Snorkel AI all point out, was the breakthrough. Its key innovation was self-attention.
Self-attention, letting the model focus on important words.
Exactly. It allows the model to weigh how relevant different words in the input are to each other, even if they're far apart. That's crucial for understanding context.
Okay, massive model, pre-trained on tons of data, but it's still pretty general at this point, right? How do you make it good at following instructions or being helpful?
That's where adaptation tuning or fine-tuning comes in. The survey talks quite a bit about this.
Fine-tuning, like polishing the model?
Kind of. One key type is instruction tuning. This is supervised fine-tuning. You basically train the model on examples of instructions and good answers.
Where do those examples come from?
The various places.
Yeah.
Datasets designed for specific NLP tasks, real user chats like queries submitted to OpenAI or shared GPT conversations, and even synthetically generated instruction-following data like the Alpaca dataset.
And the quality of those instructions matters a lot, I guess.
Hugely. The survey stresses that. Better instructions lead to a better tuned model.
And then there's RLHF, reinforcement learning from human feedback. Sounds complex.
It is a bit, but the core idea, as the survey explains, is getting humans in the loop to guide the model towards being more helpful and harmless.
How does that work? People voting on answers?
Sort of. Humans compare different model outputs and say which one they prefer. That preference data is then used to train a reward model, which in turn fine-tunes the LLM itself. It steers the LLM towards generating responses humans rate highly.
Okay, aligning it with human preferences, that seems important. But fine-tuning these huge models sounds expensive.
It can be. That's why the survey also mentions parameter-efficient fine-tuning, PEFT. Techniques like LoRa or adapter tuning.
PEFT, what's the trick?
Instead of retraining all billion parameters, you only tweak a small, carefully chosen subset. Much cheaper, much faster, and often works surprisingly well.
Clever. Okay, so model trained, model fine-tuned. Now how do we use it effectively? The survey talks about utilization and prompting.
Right. This goes back to that in-context learning we mentioned. The survey explains you interact with the LLM primarily through prompts, giving it instructions in natural language.
And you might give it examples.
Yeah, that's few-shot prompting. Or you might give it 0 examples, just the instruction that's 0-shot. The LLM learns on the fly from what's in the prompt.
This whole prompt engineering thing seems like a new skill.
It really is. The survey emphasizes how crafting a good prompt, being clear about the task, maybe specifying the format you want the answer in, makes a massive difference to the quality of the output.
Especially for complex stuff.
Definitely. And for complex reasoning, the survey highlights chain of thought prompting, Cusho.
Chain of thought, like thinking step by step.
Exactly. You include the intermediate reasoning steps in the examples within your prompt. This encourages the model to break down the problem and show its work, which often leads to better answers for things like math problems or logic puzzles.
That's neat, teaching it how to think almost. The survey also mentioned tools manipulation. What's that about?
That's about letting the LLM use external tools. Because LLMs aren't great at, say, precise calculations, or they don't know information that appeared after their training ended.
Ah, so they can call it to a calculator? Or a search engine?
Yep, or specialized databases, booking systems, whatever. ChatGPT plugins are a perfect example of this. It extends their capabilities beyond just language generation.
Okay, makes sense. We've built it, tuned it, prompted it. How do we actually measure how good it is? Capacity evaluation, the survey calls it.
Right. It's tricky. You need to evaluate lots of things. The quality of the language it generates, its knowledge, its reasoning skills. The survey mentions perplexity as one common metric for basic language modeling.
But for specific skills?
You use benchmark datasets. Survey lists examples for question answer, like truthful QA or trivia QA, common sense reasoning, math problems like GSM-8K, MMLU is another big one mentioned in the sources. You see how well the model performs on these standardized tests.
Are benchmarks the only way?
No, the survey mentions other approaches. Human evaluation, just having people rate the outputs, and even using other powerful LLMs like GPT-4 to evaluate weaker models. Model-based evaluation.
Using AI to judge AI. Interesting. And this brings us back to scaling laws, right? Bigger models generally do better on these benchmarks.
Generally, yes. The survey reiterates that performance tends to improve predictably with model size and the amount of training data. That's the scaling law idea.
But then there's that other idea, emergent abilities.
Exactly, the unpredictable stuff. Capabilities that just seem to switch on once a model hits a certain scale, things you couldn't easily predict from the performance of smaller models.
Like the in-context learning we discussed earlier.
That's often cited as a prime example. The survey highlights this contrast, predictable scaling versus unpredictable emergence. It's one of the big mysteries.
Which leads nicely into the challenges in the future. Why do these abilities emerge?
That's a huge open question, as the survey points out. We don't fully understand the mechanics behind it yet.
And it seems like building these state-of-the-art models is getting harder for many researchers.
Definitely. The survey mentions the immense computational cost. Plus, the companies building the biggest models often keep the training data details, the exact architecture tweaks, proprietary. That makes it hard for the wider community to replicate and study them.
And the safety aspect. Alignment. Making sure they don't say harmful or false things.
A massive ongoing challenge, heavily emphasized in the survey. How do you reliably align these incredibly complex systems with human values and ensure they're safe and truthful?
Because they do make mistakes. The survey and Wikipedia both mention limitations like unreliability, especially in specialized fields, issues with structured data, and hallucinations.
Right, hallucinations generating confident-sounding but completely wrong information. That's a major problem still.
But research isn't stopping. What's on the horizon?
Lots of things. The survey briefly touches on efforts to make the context windows longer so they can handle more information at once, improving reasoning consistency, making them more efficient quantization, pruning so they're easier to deploy.
So constantly evolving.
Absolutely. It's an incredibly fast-moving field.
Okay, so wrapping up this deep dive, we've seen that large language models are, well, a huge leap in AI. They use massive scale and clever techniques to understand and generate language in ways that are genuinely impressive.
Yeah, the progress has been stunning. Pre-training on vast data, fine-tuning for specific skills, prompting for utilization, it all comes together.
They're definitely changing how we interact with technology, information, maybe even creativity. But as our sources laid out, there are still big hurdles: alignment, hallucinations, the mystery of emergence.
Lots of work still to do, lots of questions still to answer. Understanding these models, their strengths and their weaknesses is really crucial for everyone, not just AI researchers.
Absolutely. So, as you, our listener, think about all this, maybe ponder where it goes next. What happens as these models get even bigger or more efficient or better aligned? What new possibilities or maybe new challenges will emerge down the road?
It's definitely something to keep an eye on. The landscape is changing fast.
It really is. And hey, if you enjoy diving deep like this, exploring these complex topics, please do support the All Sorts podcast. Find us on YouTube, hit like, share this with someone else who'd find it interesting, and definitely subscribe.
Check out the back catalog, too. Lots of other deep dives waiting for you.
And join the community on X, Instagram, and Threads. Let us know what you think, what you want us to explore next. Your curiosity really does fuel everything we do here.
Thanks for joining us on this dive.
Yeah, thanks, everyone. Until next time, keep questioning, keep exploring.